death, which is your production code. It's completely unreadable. You have one file that has your entire application, your entire website. It's obfuscated, and you need to apply a lot of mental power to actually try and figure out what even happened. There are things that try to help you here, and you have source mappings that basically try to undo all the damage that you've done during a build step to somehow help you figure out, okay, which file is this even in, and what line is it on, and maybe it can help you jump through the call stack. Most of the time it screws up both for SAS and for JavaScript, so it's not a good solution yet. And it adds an extra abstraction layer that you shouldn't have to deal with in your development, where you want this simple model of how a website actually works. So the beautiful unicorn is not equal to the ugly horse of death, which means development code is not production code. Development code is written for humans. It is easy to consume by humans. It's easy to conceive of and to establish a mental model of. The other thing is just for pushing stuff over the wires very quickly. So that's machine readable. Human readable and machine readable code. So we need to somehow, so my suggestion is that you shouldn't use a build system in your development loop. Because if you add all of these abstractions, then you have to think a lot about what's actually happening, and you get further away from your code, and you have to know all these tools to somehow be able to debug your web page. So don't use a build system like this in development, is my suggestion. But we need some sort of automation. I said before that nobody should hand optimize their JavaScript. I know JS 1K is really, really cool, but I don't expect anyone to do that in a production application where everybody has a deadline and needs to deliver it yesterday. So let's take a look at some of the automation that is available currently that is pretty much state-of-the-art and recommended as best practice. A lot of you have probably used a tool called Grunt before. How many have used Grunt ever? It's quite a lot, so almost half, I would say. So Grunt is not a build system per se, it is a task runner, but you can create a series of tasks which is a build system for you. So Grunt works in a way where you define somehow some input files, you send these input files to some sort of transformation, and you get some output files. That is one task. You can have multiple tasks, and you bind these tasks together with configuration somehow. In the case of Grunt, you have a lot of configuration because for each task you basically need to do a lot of repetition. You need to tell it, okay, we're talking about these files, and then we're doing some transformation to it, and we're writing it to these files over here. And then the next task we repeat, okay, these files that are just left over here, here's where you find them again, and then we do the next step, and I've seen Grunt configuration files of 1,200 lines, which is probably pretty extreme. But let's do some fun little hands-up game here. Who of you who have used Grunt have had a Grunt configuration file that is less than 100 lines? Hands up. That's not that many. Less than 200 lines. 300. Still hands up. 400 lines. Still hands up. 500. 600. 700. 800, 900 lines. Okay, so 900 lines of configuration. I would argue that is not necessarily simple. I wouldn't expect my junior developer to go in and say, oh, we're using Grunt. Oh, cool, Grunt. I know what Grunt is. I'll just go and read this 900 line configuration file and then just adapt it to my needs. That's simply not feasible. So other people agree with me on that, and somebody has come up with Gulp, the next cool name in the series of many build tools. Gulp has a bit of a different strategy. You still need to define what input files Gulp needs to work on. Then you send those input files to some sort of a transformation. But instead of writing your output files to disk, you simply send them, you pipe them using node streams or node pipes to the next transformation, and to the next transformation until you're basically done transforming that piece of the code, and then you get your output. That means that Gulp is extremely good at doing many things in a row. It is extremely good at transforming code that has similar properties. So it's, for example, you wouldn't be able to create a pipe that takes both CSS and HTML and JavaScript at the same time, and then just does one pipe for that. You would identify different pipes, so one for CSS, one for HTML, one for JavaScript, probably one for images, and you have all these running in parallel and they stream, and it's pretty quick. So it speeds up a thing that is problematic, and that's pretty good. So in that sense, both of these tools actually join a long-standing history of Unix tool wrappers. What they're actually doing is they're just saying, I have this transformation that's somehow applied to my code. It is encapsulated in a simple tool that knows to do one thing and do it well. That's the Unix philosophy. So the simple tool doesn't know anything about the context. It just needs a bunch of files, and it will do some things to it, and it'll output something, and it's up to you to figure out where the files are, give it to it, and it's up to you to handle the output. That's exactly the same that happens in Make, in Jake, in Drake, in Ant, in Maven, and in all of these tools. I mean, we make a lot of tools in JavaScript. This is not new. Unix has made a lot of tools in many years, and but they're all pretty similar. I mean, in Make, you basically manually define your dependency chain. So this file depends on this file. Make will automatically make sure that that file exists on disk by running the appropriate tasks. So it's not that dissimilar from Grunt or Gulp. But they all have a problem when it comes to compiling web for transport, because all of the other programming languages that basically spawned all of these Unix task runners, they have similar properties in that they use programming languages that have pretty strong conventions on where to find things. In C, you will always know that, okay, I have a header file, I have a C file, which means that my output file will be at the same location, just with a different extension. That's a powerful convention to be able to build on. So you can have programming languages that have import statements, and they automatically know where to find the files. But in web, it's different, because there is basically very few conventions, and if you break them, you're fucked. But the convention is that you can place things anywhere. You just need to have a URL that points at it. So that's basically how the browser makes sense of your code. It looks at your HTML and sees, oh, there's an outgoing relation to an image. I'll go and fetch that image for you. And it's JavaScript over here, blah, blah, blah. It can be on a different domain, and it could be local, it could be relatively, you can have a relative URL and all that stuff. So that basically makes the specific task of optimizing a website quite different from all the other things that have come before it, because we actually need to rewrite our code in our build step, which none of the other tools need to do. So what we're doing when we're renaming and we're bundling is actually we're creating new files. I have two JavaScript files. They turn into one JavaScript file. That's a change of URL. That's a change of file name. And these things have to be reflected in the context of the web page. The problem with Unix tools is that they don't take the context into account at all. They basically just say, I need some input, and it's up to you to find that input. I'll put some output, and it's up to you to place that in the right place. And so that leads to, did I miss a slide here? Yeah, okay. The problem is that Unix tools don't apply well to things that are dependency graphs, where things depend on each other and have relations between each other. Because when you just rename a file, you need to also make sure that everything that's pointing at it, that needs to be updated as well. So a website can be described as a dependency graph, not as a list of files or a tree, which I think Broccoli tries to make that abstraction at the moment. A website is a graph, and that's very clearly indicated by if you have two HTML files, they're linking to each other by means of a menu, for example. If you want to navigate between the two, that's a cyclic dependency. You don't get that in lists or in trees or anything, so a website is a graph, and you have to take that entire dependency graph into account at all times. So basically you have your assets, which are here the white squares, and you have your relations between these assets with the green arrows. They're probably quite hard to see, but there are some arrows here that bind things together. So there's an outgoing relation from a style sheet, from a link tag to a style sheet, from CSS background image to the actual image and so forth. For those of you who know graph theory, the assets would be nodes and the relations would be edges in the graph. So the two big problems that the other tools are dealing with is the problem of one, discovery. This is why you need to write gigantic configuration files, which are basically manifest files, where the developer has to write down his mental model of the website. So he has to know the dependencies of the website, and he writes them down into a specific file order, which then get passed on to these Unix tools. The problem is when you suddenly need to introduce something new, it might get in the wrong place in the order because it's dependent on something else. And it's a really big problem if you want to delete stuff, because it's very hard to try and really establish what was the dependency graph in my code actually when you only have a flat list. So what often happens is that a lot of code is just left in there and not removed because it's really hard to do. So that's one of the problems with Grunt and with manifest files in general. And the other problem is the coherence. If you change locations, if you rename files, move them around, your dependency graph basically gets broken. So if you have a website that works, move some files, I'm not changing the URLs, I get a 404 when I check it in my browser. And that's a big problem that a few tasks in Grunt, for example, have tried to fix this by file rev and use mean, I think the biggest tasks are. When you look at the issues list, in those there are tons of issues, and about 80% of them are just pure bugs. It's not people that don't understand the API or anything, it's just bugs because this is extremely hard to solve. So that means that the easiest way to apply these tools and to actually use them in your daily workflow is to do the production build in your development step. So that means all of these stupid details that only deal with how we can put our code over the internet more quickly suddenly leak into a development loop. And this is a bad thing because it adds complexity, we have more tools, we have all the things. I mean, Phil basically made my point on this, so I won't iterate on that again. So these are some of the anti-patterns that you would see in a lot of development workflows, probably in your own as well. You would have things like file renaming, you will have things like bundling, you will have things like spriting, which is basically bundling for images, and you will have compression. And when you do that in development, you need to undo it all with source maps and all that stuff. And the reason why they do this is basically the workflows that you set up with Grunt and Gulp at the moment actually has you working on raw resources that are not a working website. You need the system to assemble it into a working website. So you're actually never working on anything. When you have a file reference, an outgoing file reference in your CSS or in your SAS even, it's not even pointing at a thing that is on disk where you expect it to be. But it becomes some CSS at some point that hopefully points at the right position. And that again, it adds a lot of complexity, and you have to know the setup of each part of the tool chain. And it's just, yeah, it's not good. So I'm not a fan of this way of doing things. So there's something that's missing somehow. I mean, how can we gain the simplicity back from the 90s of just developing websites, just thinking about writing our HTML or CSS or JavaScript, linking them together, opening the browser, seeing it works, and then assume that we can somehow put this into production. It isn't provided to us. So we thought a lot about this back in the early days when Steve Souders was basically formulating his 14 rules, 12 rules. There's a number of rules for what you should do for web optimization. State of the art back then was a Java tool, which was also Yahoo developed, which was probably Yahoo compressor, Yahoo builder. There was some Java thing with a lot of XML configuration. It wasn't that dissimilar from Grunt. And it was hell to use, basically. It was a huge manifest file and it had all the flaws that I just told you. So we put our heads together and thought, we need to somehow make it easier for the developer. So we need to encapsulate complexity in our tools instead of pushing them over to the developer. And the idea we had was that we should use the source. This is a bit unreadable because it's rescaled. It says use the source. Because what you're basically doing when you're writing a website, you're already telling the browser how to load stuff. It knows how to load stuff out of the box. So why don't we have tools that do that for us in exactly the same way as the browser does? So that's the premise. your tool for the web should work exactly in the way that the browser does, because then you could get all of the nice abstractions that the browser has, and you can work towards that. So it establishes an interface that is just make a working website. If it works in the browser, then you should be good. That would be the best practice that we saw. And the project that we came up with was Asset Graph. Ideally, to begin with, this was just a way of scratching an itch. I've been working on rich internet applications for 15 years or something before it was a thing. So it's been large code bases, it's been webmails, calendars, systems, big. Yeah, it's always been big. It's always been behind a login screen. It's always been several megabytes of transfer, basically. So we had big code bases we needed to organize. We had things we needed to push over the wire quickly. And what we needed was a build system that made it easy for us. And along the way, we figured out this abstraction that is so cool that I have to talk about it, because it might not be easily approachable yet, but I think it's a really, really cool idea, and you should know about it. So Asset Graph is basically this graph model. It is trying to create a model of what the browser actually does and how the browser behaves. So in the background image here, that's completely, you can't see that. Okay, but what it actually does, it loads your web page, and then it starts statically analyzing your code. So it basically figures out, okay, these HTML tags, those are images. This is the URL. I should probably look over here on the file system for this image. Then it loads the image. Same thing for CSS, for JavaScript, and all of this is basically happening recursively. So it's a web scraper, and it works exactly like a browser. Which means that your configuration suddenly reduces down to almost zero, because you only have to give it basically your front page, and then it goes and can scrape your entire site on disk or on the internet, because if you're using the file protocol, the HTTP protocol is really very little, a small difference, so it's easy to do both. And once you have this graph model, you can do all sorts of really, really cool stuff, because inherent in this graph model, first of all, you have the discovery part. You have the parsing, it just scrapes your stuff for you, so you don't need to define all this input configuration for it. And you have an implicit or an explicit graph coherence. So if you, instead of moving files around on disk when I'm bundling, for example, bundling is one of the easiest operations using Unix tools. Basically just cat some files together and you have an output file. But when you do this using the graph methods, you also get the guarantee that if you rename a file, anything that points to it will actually also be updated. So the only thing you need to do to move a file is actually just rename it. And every href that points at it will be completely updated and pointing at the new file in the new location. So things that are really difficult, like revving files for far future cache expiry, which you usually would do. I think the best strategy at the moment would be having a hash of the content of the file, so that's a unique identifier of the file. You have that as a file name, but that means that you have to traverse the graph in a specific way. You have to do a post-order traversal, which ensures that the thing that doesn't have any output dependencies is the one that gets resolved first, because all the other ones will change their MD5 sum based on what it's pointing to, because the outgoing file name has now changed. So these changes reflect down the whole graph, so you have to traverse it in a very specific way in order to guarantee that you won't accidentally update a file and then not have the hash update. So this becomes extremely easy when you have the graph model. So the pipe that you use in Asset Graph to apply different tasks to transform your code basically looks like this. Instead of having a configured list of input files that go through a transformation, you have an already established and complete graph of assets, this dependency graph, that then has transforms applied to it. And what you get out is an asset graph that is exactly, it's the same data model, but all things have changed inside. And the cool thing is that between each of these steps, there's a guarantee that the website actually works, which you don't have in any of the other tools, because you basically have to get to the endpoint, and then it has assembled the page that works. If you stop anywhere in between, you're basically lost. this is an extremely nice guarantee to have because you can do things, inspect it, and see what happens, and then move on. So that's the theory. Let's see how we can actually use it. So there are two things. So I talked about us scratching an itch. What we needed was a build system. So we made a build system, but we made the build system as a separate project. So we have Asset Graph, which is the core abstraction, the core module that has the data model, that has the relations, that has the assets, that knows how to parse and how to extend this whole model. And then it has some transforms that are easy to do because they don't require any new dependencies. And then we have a separate project which is called Asset Graph Builder, which basically is specifically tailored towards optimizing single-page web applications or static websites. It can do dynamic stuff, but it requires some extra thought. So one thing is that you can build your own tool. Asset Graph, I would say it's not something that you can use out of the box. It is a tool maker's tool. It's a power tool that people that know what they want, what transforms they want to apply specifically, and not all of the others, they can use it and they can assemble things themselves. One of the problems is that this is a completely new paradigm from the file-based paradigm that you're probably used to, which means that it has quite a steep learning curve. And I'm still not proud of our state of our documentation. So I'm really hoping to improve that and start blogging more about this, so there are examples that you can read up on. But that's a bit of the bad news. That's if you want to do everything yourself, if you want to have a very specific tool, you probably shouldn't take this because it will require quite a lot of time. But the good news is that you can use the already established tools that we built, which should work out of the box. So Asset Graph Builder is basically our attempt at a kitchen sink of build tooling for any website. So it has support for things like Angular templates and knockout bindings, and it has basically everything that we can, every best practice that we can find, and every way of modeling different dependencies, underscore templates, require JS plugins, all that stuff. It has that in there, so you don't need to think about it. And I made a small grunt wrapper for it, which is basically just calling our existing Asset Graph Builder. It's not using the grunt ecosystem at all because the grunt ecosystem doesn't really fit into the paradigm. But if you use grunt already and have it on your site, grunt reduce is a really, really good default setup to work with. You could try it out in 5 minutes and see if it works for you, if you have a static web page or application. So somehow I needed to explain this to people. I need to prove its worth, that it is actually as easy as I'm telling you. So I talked to the Taste.js people, the guys who are responsible for the To-Do MVC project. If you don't know it, To-Do MVC is basically a presentation of the different JavaScript frameworks. They implement the same application in all the different frameworks, which gives you sort of a reference of what a best practice application would look like using this specific framework. So I talked to Adi Osmani on their ISV channel. I don't know if you can read this. I'll just read it aloud. I told him, I have this thing. I want to prove that it's good. So I was thinking of building all the To-Do MVC applications with it just for demo purposes. And he is apparently laughing out loud and saying, if you're able to do anything with all the To-Do MVCs, I'm impressed. Even a few would be something. And I basically took that as a challenge and accepted it. And that is how the To-Do MVC challenge came to be. The To-Do MVC challenge is a website that I created, which basically has the concept that it will take all of the To-Do MVC applications. I think there were 60, 70 applications or something implementing this To-Do MVC thing. And my thought was, okay, since the To-Do MVC applications are they don't have any build concerns inside them at all. So they're exactly the best practice that I want people to be able to write in their development loop. Which means that it already works in the browser. That's a guarantee because otherwise it wouldn't be accepted. So it should be perfect for me as an example. So I set these 3 rules. I have to use the original source of the application without any alterations. which means that it has to be good enough that you don't have to think about build abstractions. You should just think about making it work for the browser. The build system must be able to build without throwing any errors. So throwing errors would usually indicate that something is wrong. Sometimes it doesn't throw errors during the build and it still doesn't work, so the third rule says that the build application must be functionally intact. So those are the very simple rules of the to-do MVC challenge. And the first iteration of this I made back in January, where I actually went through all of them. I actually got a 40% success rate out of the box. So 40% of all the to-do MVC applications were building successfully without any change at all. You just plugged it in and then you had a working production to-do MVC application. Naturally, this spawned a ton of bugs because suddenly we were throwing real-life code at AssetGraph, which it hadn't seen before. It's basically been running internally in a company. So it was very targeted towards our assumptions on how the best practices are. But there are a lot of weird practices out there, and we should ideally support all of them. And so the current status is, after we've done a massive bug fixing spree, is that we're actually able to build 80% of the to-do MVC applications. I would say that's quite a lot. The remaining 20% are really difficult to get. That's where we come to one of the downfalls of AssetGraph. In order for this to work, the data has to be inside the data model. The data can only get inside the data model if we can statically analyze that there is something that includes it. Which means that if you have things like a string in JavaScript that is a URL, but it's not annotated in any specific way that it's a URL, then AssetGraph just says, okay, that's a string, I can't assume anything about it. So there are a lot of places where you have strings in JavaScript that have special meaning. You would have templates in Angular as a specific example. You have require.js and all that stuff. But they have very well-defined syntaxes, and we've actually implemented the detection of those syntaxes. So require.js does actually work out of the box, and AngularJS templates do actually work, even though they're not annotated in any special way. For the rest of the cases, which are hopefully not going to be that many once people start using module loaders, you need to do a special annotation. So we have a function call, a fake function call that says get static URL, and AssetGraph knows, okay, this is special, I should treat this as a URL. And the function in your development runtime is basically just returns the same string that its input was. So 80%, I think that's pretty cool. The remaining 20% are primarily not supported because most of them are actually using custom module loaders. So they have exactly the same problem that I just described. They are magically translating strings into locations on disk. And it takes a lot of work to actually figure out and reverse engineer people's weird special module implementations. So we opted simply not to. It supports CommonJS, it supports require.js. We have some big frameworks are specifically implemented. But if some of these frameworks like Yahoo wants its module loader supported in AssetGraph, they'll have to come with a pull request. I don't see custom module loaders being the future of front-end development, so I don't want to focus our efforts there. I highly recommend using ECMAScript 6 modules or require.js in the front end. So I think it's a success, but then you get all the people saying, hey, this is just yet another build system, isn't it? It is true, it is a build system, or actually I would say it's a build tool specifically, not a system per se. It is. I don't agree with it being another one. It is a different one because I think all of the other existing build tools are basically still running in the same paradigm. We're doing something with a Unix tool, and we have some scaffolding around it. We're optimizing for doing as little work as possible. Where Broccoli is probably the most performant one of those because they know how to do incremental rebuilds and stuff like that. But my idea is that we shouldn't even do that. We should just not build anything in development. So the interface is make your stuff work in the browser. Don't worry about the rest. AssetGraph is on Twitter on the account called AssetGraph. It has a website, assetgraph.org. I recommend going directly to the GitHub account because currently the website does that. We're on Freenode in the AssetGraph channel. There's not a lot of activity, but I'd really like there to be. Some of the details, it's written in Node. Basically, we came up with this idea at the same time where Node 0.2 came out. So this was basically the dawn of really, really good front-end tooling. Suddenly we had the abstractions of HTML DOM. We had abstract syntax trees for JavaScript. We had CSS on, and all available in Node. So basically that we developed in parallel with Node. It's completely open source. It's a 3-clause BSD license. And the first commit was actually in December 23rd, 2010. That's 8 months before Grunt was released. So it's not a new idea. It's not like I'm introducing something new right now. We've just been really, really slow at figuring out that this is useful for other people than us, and that you should probably take a look at it. So currently it's in use by the leftmost, I don't think you can see it, it's the logo for one.com, it's a web hosting company. That's where I worked at the moment, at the time. And basically me and a colleague did this crazy idea, and we ran with it, and we got to open source it. So everything at one.com is built using this. All the front-end web applications, including they had like a tool, draw your own web page, and we'll do the front page type thing and actually make it into a web page for you. Those are also optimized using this tool, so it's being applied to a lot of things there. It's actually been used by Adobe Typekit. They have a practice website which got released not that long ago, I think 3 weeks ago or something, which is also optimized with this build system. And another previous company where I worked, Falcon Social, is also using it. So this is doing production builds. It's stable enough for that. It has been doing production builds at one.com for at least 3.5 years. So it's not like this is completely on the edge. So I have a lot of demos. I'll just need to check the time before I land here. What do I have? 10 minutes, 15 minutes? Okay. So first of all, AssetGraph Builder, the build system that magically does the right thing. I really want to demo that. And what I have here is basically the command line that I need to copy in order to do a production build of one of the to-do MVC applications. So I'll just copy that. This is, this guy build production is a binary that AssetGraph Builder exposes, which I've installed globally. This is the root to the index file of the jQuery to-do MVC application. And this is me telling AssetGraph Builder where to output the build files. This is all the configuration that you need. There is nothing more that you actually need to do. I find that quite amazing. So I'm switching to terminal. Is this big enough for people to read? Maybe I should do it like this. Okay, I am pasting in the command line that I just copied, and I will say that the output is the delete me directory. So it goes ahead and it parses the files, and it does all of these crazy things that we identified are best practice for optimization. And it outputs one HTML file, one PNG file, CSS, JavaScript, so a total of 4 files. And I can show you the output directory, which is called delete me. It basically looks like this. So the best practice for static asset delivery nowadays is having the hash of the file content in the file name itself, which we have here basically. So all the files have been renamed to all the files that are actually file future expires cached are renamed like this. And we put things into a static directory, which means that this is easy for you to just read using a CDN, and you can apply your file future expires cache headers to that directory specifically. So anything served from here, you can just save it forever. And basically what you can do when you have a new build, you just append to this directory. So people can even be loading old versions of your website, old static assets, because you just treat this as a bucket where you just put up append only files. And the index then just then points at these. So I can start up a static web server. Oh, right. I should probably give it You know when you have a lot of development services used at the same time? That's really annoying.
Yeah.
No? Oh, I know why. Live demos. Okay, part 4001. Hopefully you don't have anything there. Okay. I'll open Chrome. Oh, you should type. There we go. And there you see the jQuery to do MVC application, and it actually works. It should probably apply some chaos monkey stuff to this to ensure that it does. But I've tested this, and it actually does work. So the source code looks a bit like this.